Today, we want to look at graphs of sine and cosine, and more importantly, the effect of doing multiplication or addition before or after we do the sine function. So this goes back to looking at an expression and reading what's happening in the order of operations on that expression. Not thinking in terms of PEMDAS, because PEMDAS is trash, and just thinking in terms of what's happening to turn the x into the y. What operations do we perform, and what order do we perform those operations? This is especially important because we've been making a distinction between multiplying and adding before or after the trig function. So here, that means there are going to be 4 places that we could put an operation, or 4 operations and locations. 4 combinations of operation and location. I should probably write a script before I do these things. A professional teacher would do that, but y'all don't have that, you're stuck with me. So there it is. We can do multiplication before, multiplication after, addition before, addition after. 4 to choose from. Here are generic versions of sine and cosine, where I have a times the sine of b times the x minus c, in parentheses with a minus c for reasons, and then a plus d. Let's break down the order of operations. Let's look at what happens to start with an x and think about what happens to the x in each of these expressions. So I start with an x, and I know multiplication goes before addition unless there are parentheses that tell us to switch around the order. Unless there's some kind of grouping symbol that says do it the other way. And in this case, we have that. We have parentheses around the x minus c. That's a grouping symbol. And so the first thing that happens to the x is we subtract c. So I'm just going to shorthand it over here. I said first subtract c. After we subtract c, we've got this x minus c quantity. The next thing we do is we multiply by b. After we've multiplied by b, we've taken care of everything in the argument of the trig function. So the next thing to do is the trig function, either sine or cosine. So notice that the c and the b represent addition and multiplication before the trig function. This is stuff before the function. And we know that operations before the function will have a horizontal effect on the graph. So before the function, we're going to see some horizontal stuff out of the c and the b. After we do the trig function, we've got the cosine of all this stuff. The next thing, we've got multiplication by a, and we add d. Unless there's some grouping symbols, we do the multiplication before our addition. So the next thing is to multiply by a. And then finally, we do the addition where we add d. And these are the operations that are after the function. So we have 2 places that we can do the operation, before the function or after the function, and we have 2 operations to choose from, addition and multiplication. There are clearly other operations that we could perform before or after, but these are the ones that we start with because they give us those nice sinusoidal graphs that we're looking for. So let's take a look at each one of these changes, that multiply by a, multiply by b, subtract c, and add d. Let's look at each of those changes and classify what they're going to do to the graph. Less so in terms of the graph of a trig function, more so just in terms of the graph in general. So let's start with a. Use the same location. So a is multiplication, and it's happening after the function. Since it happens after the function, it's going to be some kind of vertical change. And since it's multiplication, it's going to be a stretch or compression. So A is multiplication after the cosine. Since it's multiplication and it's after, it's going to be vertical and it's going to be a stretch or compression. Multiplication afterwards is going to be a vertical stretch or a compression. When we look at B, B is multiplication and it happens before the function. So B is multiplication before the cosine. And so that's going to, multiplication is going to be a stretch or compression. Before is going to be horizontal. Next, we'll just continue going from left to right. We get to this minus C. Minus C is addition and subtraction. So that's going to produce a shift, and it's happening before the function. So it's going to produce a horizontal shift. So the C is addition before Before is horizontal. And addition is a shift. Keep the same shape, but move it left and right because it's horizontal. And then finally, we have the plus D. Plus D is taking place after the function, and it is addition. So I've got addition after. After is going to be vertical, and addition is going to produce a shift. Keep the same shape and move it up and down. So this is all just generally what we're reading. This could be where sine and cosine could be any function. I can replace sine and cosine with just a generic function, and these are going to be the effects that we see on the graph. In terms of sine and cosine, a couple of these have names. So the multiplication after, that's going to be the vertical stretch or compression. That's going to change the amplitude. So this A is going to change the amplitude. For sines and cosines, this is going to tell us about the amplitude. So amplitude is how we describe vertical stretching in our sine and cosine graphs. The B, multiplication before the trig function, is going to be a horizontal stretch or a compression. And that's going to make adjustments to the period, because the period is how we describe the horizontal stretching and compression. And we do have to remember that the baseline period is 2 pi. So the period is 2 pi divided by B. The baseline amplitude is 1, so we just get to read it right off the tin. But we have to do a little work to figure out what the period is, because the baseline period is 2 pi, so we have to divide it by B. Addition after is going to move the top, the middle, and the bottom, but the distance is going to remain the same. So the addition after, the way we're going to interpret that for sines and cosines is this is where the middle is. So the plus D is where we're going to find the middle of the graph. I'm going to put that in quotes, because I just refer to the top, the middle, and the bottom. So the plus D is going to tell us where the middle of the graph is. And then finally, the horizontal shift, the minus c, this is going to tell us where the graph starts. There are 4 possibilities of where the graph starts: the top, the middle going down, the bottom, or the middle going up. And each one will have an effect on whether we choose to write sine or cosine, and whether we write a positive or a negative value for a. So just in general, I'm going to say that the horizontal shift is where we're considering the start of the graph. Even though the graph goes on forever in both directions. Any questions? So we looked in general at addition and multiplication before and after the function, and now we've put that in terms specifically of sine and cosine. So at this point, I want to switch over to the graphing calculator. So I'm going to switch us over to Desmos, and I have each of these functions programmed in. So let's see. Here it is. So you should be looking at my graphing calculator. And I have just generically y equals sine, a sine b of x times x minus c plus d in blue. And then in orange, I've got the cosine. Right now, everything is set at the default. So the amplitude is 1. The period is 2 pi. We can see the period by going from the top of the cosine to the next top of the cosine. And we can see that the change in x's is from 0 to 2 pi. We can also look at the middle going up on the sine and the middle going up on the sine. 0, 0 to 2 pi, 0. We also notice that the amplitude, if we look at the cosine, the top is at 1 and the bottom is at -1 and the middle is at 0. Top, middle, and bottom are all y coordinates. The period is the distance between x coordinates. So let's turn off one of these. Let's turn off the cosine. And we know that if we make adjustments to a, that's going to change the amplitude, but the period will remain the same. So notice that the period here's the middle going up to the next point where we're at the middle going up. So it's from 0 to 2 pi. If I adjust the amplitude, notice that the period is not changing. The point from the middle going up to the next middle going up is still from 0 to 2 pi. So as we adjust the amplitude, we can see that we're just stretching the graph vertically, but when y is equal to 0, multiplying 0 by anything doesn't change anything. So that's why all the x-intercepts stay where they are. One thing that we want to point out is that, well, first of all, when a is equal to 0, then that just zeroes out the entire graph because we're multiplying everything by 0. But notice that the points, I described these 2 points, 0, 0, and 2 pi 0, the beginning and the end of one cycle of sine. I describe these points as being at the middle going up. Going through these points, they're both at the middle, but these points are the middle going up. Here at the point pi 0, I describe this as the middle going down because the direction of the sine is going down at pi. Notice what happens when the amplitude drops negative. So the amplitude goes, as the amplitude drops down, the graph gets shorter. When the amplitude gets to 0, the graph zeroes out. Then when the amplitude goes negative, the points where we had the middle going up are now points where the graph is the middle going down. So when a is negative, it changes the direction of the graph. So that's the difference between starting at the middle going up or the middle going down. Let's reset back to the default. The horizontal, the vertical shift, the D, that's the other vertical effect, and changing the value of D moves the graph up and down, but notice that the amplitude stays the same. So if I look at, if I make a horizontal line where y is equal to D, I'm going to, I don't want blue because everything's blue already. Red will stand out. So I'm going to have a red line at the middle. And so if I set the middle in motion, so notice that the middle is staying where it is. And we're just moving the graph up and down. We're just doing a vertical shift. Notice that the top and the bottom are also not changing. If I add the top, y is equal to d plus a, and the bottom, y is equal to d minus a, then when I put d in motion, that just moves the whole thing up and down. It maintains the amplitude, it maintains the period. It just takes this whole picture and moves it up and down. I don't know if that's going to show up on the video, but that was my dog choking on a chunk of bone, having to spit it up. So good thing I don't edit my videos, otherwise you'd miss out on that. So let's shift our attention to, turn these off. Let's shift our attention to the horizontal stuff. When the horizontal, the period, the horizontal stretching and compression will be determined by the value of B. So as B goes up and down, we can see that the period is changing. Like a spring compressing and then stretching out again. Also notice that we have a similar effect. When B is equal to 0, that just drops everything out because we're just looking at the sine of 0, and the sine of 0 is 0, and it flatlines the whole thing. Notice that when B is positive, the 0, 0 point is at the middle going up. And that as long as B is positive, 0, 0 is the middle going up. When B drops negative, 0, 0 is now the middle going down. So it changes this direction. Also notice that when B is large, then the period is getting smaller. We can think about the value of B as how fast we're cycling through a circle. So when B is equal to 2, we're going to go through one cycle twice as fast as normal, from 0 to pi instead of from 0 to 2 pi. So the default, when B is equal to 1, one cycle takes 2 pi units. But when B is equal to 2, we're going through a cycle twice as fast. And or we could think of it as we're going to get 2 cycles from 0 to 2 pi. So we could think of the 2 as we're going through the circle, around the circle twice as fast, or we could think we're going to get 2 cycles in one circle, or in 2 pi units. So when B jumps up to 3, we notice that one cycle is 2 pi over 3 because we're going around the circle 3 times as fast. We could also think of the 3 coefficient of x multiplication before the trig function as the number of cycles we're going to get from 0 to 2 pi. So there's a couple of ways of thinking about the effect of B. Notice that if we adjust the value of C, the C is going to shift things left and right. The period is not changing. We're just taking this same shape and moving it left and right. if I think about where the middle, the starting value is, the starting value, we're starting off at x equals the value of c. So I'm going to put a graph at x equals c. And so when I move c left and right, we can see that that starting value, we're always at the middle going up. We're at the middle going up. My dog is having the zoomies right now. It's really funny. So the starting point is at the middle going up. Now, if we think about the end of the period, that happens at the period, the end of one cycle will be at 2 pi divided by b. So I'm going to put that. I'm going to graph not x equals d over a, but I'm going to say I want x to be at 2 pi divided by b. So now b is going to be, I'm going to have the green line at the end of a cycle. So if I change b to 2, then I'm going to have that green line at pi. And if I put the c in motion, we're shifting, oops. There we go. And okay, I forgot to make it move with c. So if I put the default c is at 0, I see my start. The red line is where we're starting at the middle going up, and the green line will be at the end of the first cycle at the middle going down, in this case at pi. And then when I set c in motion, now the red and the green line should both move back and forth. I don't know if it's showing up on the audio, but my dog has grabbed his squeaky duck, and he's going to play you the song of his people. And we're just going to be mesmerized by the graph moving back and forth. If we change the value of b, that'll change how far apart the red and the green are. So if b is at 1, the default, one cycle is from 0 to 2 pi, and putting c in motion maintains that distance. Putting both in motion, and then it's just kind of chaos. Putting them all in motion, and then we just get kind of chaos. Any questions? All right. So what we want to notice is we want to categorize the changes in the graph, reading things before or after, reading where we start, where the middle is, and calculating the period. We want to be able to calculate all those things. We want to know what the graph is going to look like and what the points are going to be on the graph. So let's switch back over to the board. There we go. So what does all this mean for us? I want to be able to write down an equation, and I want you to tell me the amplitude, the period, the middle, and where things start. So let me be a little bit more clear about where things start. So when we have a sinusoidal graph, so it goes down. We've got a top, a middle, and a bottom. So the places I refer to are the middle And then we have a top. And we have the bottom. These are not official words, names for things. These are just words that I use to refer to them. So the four choices of starting points are what I refer to as the middle going down, the bottom, the middle going up, and then the top. So I say this is the top. I refer to this middle as the middle going up. I refer to this as the bottom. And I'll refer to this one as the mid going down. So those are my four starting points. The top, the middle going down, the bottom, the middle going up. And they just cycle through. Bottom, middle going up, top, middle going down, bottom, middle going up, top, middle going down, and so on forever. So it's ridiculous to call this the start, but that's what I call it. So each of these is assigned to a trig function, sine or cosine. And each of them will have a positive or negative value of a. So here's how I assign them. I think of the top as positive cosine. So if a is positive and it's a cosine, we'll start at the top. Positive cosine starts at the top. And by positive cosine, I mean a is positive. If a is negative, then cosine will start at the bottom. So the bottom is negative cosine. And by that I mean a is negative. So you can guess where the middle ones are going to be. So the middle ones are going to be the sine. There's a middle going up and a middle going down. One of them is going to be positive sine, one of them is going to be negative sine, and it's pretty much exactly what you would guess. The middle going up, is going to be a positive sine. Positive sine starts at the mid going up. That is, a is positive. That's the positive part of positive sine. So this positive business means that a is positive. And then our fourth choice is the middle going down. And we'll say that negative sine starts at the mid going down. So if we switch over to our graphing calculator again, oop, everything's all messed up. Let's turn these, let's set these back to the defaults. And let's look at cosine. We looked at sine a lot, so let's look at cosine. At cosine, the top is at 1 and the bottom is at -1. And our value of c is equal to 0. We identified the horizontal shift as what I call the start, even though it's ridiculous to refer to this as a start. But if I mark with the red line the value of C, notice that it moves, the values of C move with the top. It's because A is positive. So if I move C, the top is always, the starting point is always at the top. So whatever the value of C is, when C is 1, the top is at 1 because the amplitude is positive. If I drop the amplitude negative, we know that flips everything over. And now, when C is equal to 1, the graph is starting at the bottom. And if I adjust the value of C, the bottom is moving back and forth. So if A is negative, the graph starts at the bottom. If A is positive, if A is negative and it's cosine, so -2 cosine starts at the bottom, and the starting point is where whatever the value of C is. The default is 0 when C is positive. We shift over this way, and when C is negative, we just shift over the other way. Same thing happens with sine. Switch back to defaults. Sine, a positive sign starts off at the middle going up. Whatever the value of C is, the starting value is the middle going up. So C is identifying where the middle going up is happening. If A is negative, then C is telling us where the middle going down is at. So here's C is -2.5, and we're at the middle going down. So -1.5 sine will start at with a C of -2.5, says that -2.5 will be at the middle going down, and then move that back and forth. So this is what I mean when I talk about the cosine starting at the top. That tells us that if A is positive and we have a cosine, then when we find the value of C, that's going to be the top. That's going to be where things start. And like I said, it is ridiculous to call it the start because the graph goes on forever in both directions. But it's handy to identify where the top, the bottom, the middle going up, or the middle going down is going to be. So this is definitely some local language specific to my particular trig class, where I talk about positive cosine, negative cosine, positive sine, negative sine, and I talk about where the graph starts. So here's the game that we want to play. I want to be able to give you a graph. I want to be able to give you a graph and have you identify or have you decide what the function should be. I want to be able to give you a graph and have you come up with an equation. So the game is going to be given a graph, find the equation. And the other game will be given an equation, draw the graph. Notice that when I said find an equation, that's because there are a lot of different ways to describe the same graph. But if I give you an equation, it will only have one graph. So if I give you an equation, I tell you where the bottom is, the middle going up, top, the middle going down, If I give you all 4 of these points, you have 4 choices of where the graph starts. You can write for any equation, for any graph, it will have a representation with positive cosine, negative cosine, positive sine, and negative sine. So any equation or any graph, yikes, has representation as positive or negative cosine and positive or negative sine. So you can choose to always write positive cosines and just say all my graphs will be positive cosines. Or you can choose your graph could be always negative sines. Don't do that. Don't just pick one. Also notice that since the graphs are cyclical, there's a bottom here. There's also a bottom here. So we have, if we start at the bottom, we can write an equation for the graph in terms of negative cosine. But we have an infinite number of choices about how we represent the graph with negative cosine. Similarly, positive cosine, positive sine, negative sine. There's an infinite number of bottom points. There's an infinite number of top points. There's an infinite number of middle going up, infinite number of middle going down. So that's when I say find an equation. 4 different representations, but each of those 4 has an infinite number of representations. Gives us 4 times infinity is still infinity. At least it's a countable infinity, so we got that going for us. All right, these questions will be in the form of a discussion. I'm going to post a picture of a graph of a sine or a cosine, and y'all are going to come up with as many different descriptions, equations for that graph as possible. All right, that's going to do it for today. That's going to do it for this week. I'll see y'all on Monday, and thanks for playing.